Yeah, the talk that I felt like I can start today talk about is the application of natural language processing in healthcare, but a broad review of what's currently going on in the field and what, at least in my perspective, the future of NLP in healthcare is going to look like. And without any further delay, I would like to get started with the slide. So if you are interested in AI in healthcare and NLP, I believe you're in the right session. Um, so I thought, because probably this conference has broader audience than just specifically NLP, I started with a quick introduction about NLP. What is NLP? It's basically teaching machines how to understand the human language, as well as being able to generate a human-like language. And if you have been following the news, there has been tremendous improvement in the machine's ability to understand the human language. I believe many of us have these devices at home that we use for like voice recognition, such as Alexa or Google's devices. And we see how improvements on a daily basis are happening in these. And that's thanks to the improvements behind the scene, which is the NLP side. So I'm showing here some examples of how this teaching of the machine to be able to analyze and understand the human language and generate can be utilized in different contexts. Some about dependency parsing example on the top, some about understanding the context and summarizing it as the two examples below. In terms of what is going on, there has been quite a lot of improvement since about 2018, I would say, in the NLP domain. And this is thanks to improvements in the language modeling that happened proposed by Google initially. And then since then, it has just been booming. Like if you look at the conferences, every year, the number of publications are increasing in the NLP side. And it seems to be like a kind of revolution going on in the domain compared to traditional and classical NLP. What I thought in 2020, what I can summarize the trends that are going on into 4 categories. One would be on the data mining. So as we know, there's lots of data being captured in the form of text. Being able to structure this data, to summarize it, it takes the action out of it, and even run analytics on it gives a huge capability in different fields such as finance, healthcare, and other domains. The next, I believe all of us can appreciate the improvements we have seen in the language modeling and translation. I don't know how often you guys use Google Translate. The new capabilities in Gmail that we see in the autocomplete, like as soon as you type a couple of words, it suggests the rest of the sentence for you, or autocorrections. These are like organically, we see it's coming into our different applications in our day life. And it's all like because of all the improvements we are seeing coming in the NLP domain. The next, I would categorize it under customer service. Pretty much all the websites that I go these days, there's a chatbot popping up on the one side of the screen and trying to offer some help. These are kind of could be in the form of a Q&A, it could be as a form of virtual assistant. And we see more and more of adoption of these technologies in the customer service. The biggest, I think, news in this would be the acquisition of basically MetaMind by Salesforce, which shows how important they recognize the capabilities of AI and NLP are bringing to customer service. And finally, in the domain of security and surveillance, in the social media and in the advertisement, there's a lot of NLP capabilities embedded. And these are like, I'm referring to, for instance, Facebook, Twitter. There's a lot of text data being created, but being able to analyze this data for the sake of sentiment analysis, for product reviews, and etc. There's a lot of opportunities for NLP, and we see a lot of interesting outcomes out of it. It helps in filtering applications, for instance, as all these posts are coming online, of course, there's requirement for a mechanism to filter and basically irrelevant content. In terms of technology highlights, I try to basically, in my opinion, come up with the top 3 in 2020. Even though bidirectional encoder representation from transformers, which was initially introduced by Google in 2018, but we see still this is one of the hottest topics even in 2020, and I'm sure it's going to continue. BERT came out in 2018, different flavors of it coming in 19 and 20. Albert, Roberta, Struckbert, Distillbert, TinyBert. These are the efforts from the community in decreasing the complexity of the BERT language model, but at the same time maintaining the performance. In the middle, you will see the specifically tuned for special domains efforts on the BERT model. So BioBERT is for biomedical context, and SciBERT and Clinical BERT and SpanBERT. These are all like the models being proposed by different research teams to provide a better tuning of the general language model for specific applications. And finally, the last column summarizes some of the efforts in basically in the space of transfer learning. So taking the BERT language model and creating one for specific languages. MBERT is a multilingual BERT language model. Beto, Spanish. Alberto is Italian. Rubert, Russian, and Camembert is the French one. As you can see, people are having even fun with the naming of the BERT language model. The next highlight in technology, probably you guys heard about the news if you're following the NLP, is GPT-3, which is from OpenAI, a nonprofit organization focused on beating human in their own game in terms of technology. What does GPT-3 does? Basically, it's a multitask NLP capability. So as you can see, different basic animations that I'm showing on the right side, it shows the different purposes for using this technology. By providing a narrative, very human-like narrative, you can get very interesting outcomes in terms of code generation, in terms of basically structuring your question and providing an appropriate answer. So this is very big improvement compared to the previous version, GPT-2. And if you look at behind the scene, it's thanks to 175 billions of parameters we are tuning to generate this model, and which costs about $12 million according to the article. This is, if you want to compare it to human brain has 100 trillion synapses. So we're still pretty far to get to the human brain level of intelligence, but we are on the right track. And every year, even though this time costs 12 million, the forecast is like this cost is just going to get lower and lower. So that's the second one. And the third one, I was debating on this one, so I consulted my colleagues. I feel like the graph neural network is going to be also the biggest thing. And we see a lot more of it in 2021. What does that mean? It's related to the graph language models, graph representations. What is a graph, knowledge graph? It's basically representing a collection of interconnected entities. As we know, entities around us, they're all somehow connected to each other, either in the aspect of spatial or temporal or other ways. And basically, the graph usage in the NLP is not new. It has been used for different essential part of NLP applications, such as translation, dependency parsing, and etc. in the past. But more recently, we see adoption of it in the form of neural network, graph neural networks. And as a result, some improvements taking advantage of this interconnection between concepts to drive multitask capabilities. Having said that, I want to start now switching to the healthcare. So NLP for general domain, as I kind of try to summarize, there has been tremendous improvements in the different applications. What about NLP? So Here, I thought I'd start with a result of a survey which was conducted by Gradient Flow. It shows the adoption of different NLP technologies provided by the basically pioneers of NLP technologies such as Google Cloud, AWS Comprehend, Azure from Microsoft, or IBM Watson. And what basically the people who conduct the survey, they asked basically people from different industries, such as the computers and electronics technology, shown with dark blue, healthcare with the light blue, and finance services with the green color. I would like you to pay attention to the healthcare, which is the light blue. As you can see, the one that has highest in terms of adoption of these kind of services within the organization corresponds to the other or none, meaning that none of the technologies off the shelf could be really come handy in solving healthcare NLP problems. And this is because of many reasons that it's not really as simple as like a general language model problem, such as a general language translation or Q&A. I summarized these kind of differences in a few items. I would start with the size of the data that we're dealing with. EMR records in typical size are about 50 to 150 bytes. But if you look at the number of records in kind of a fashion that we are generating this data, we are talking about a lot of textual documents. So there's a huge requirement in being able to handle this amount of data in the healthcare space. Another challenge on the way is that the format of the data. If you're familiar with the healthcare and the imaging space, since adoption of DICOM, there's quite standardization in the format of the data. But on the text side, still we're struggling with that standardization of the textual data. Sometimes it comes in the HL7 format, the FHIR, the new data format, but like how it gets structured within those, still debatable and still quite a bit of research going on. So up to today, we cannot really say we have a really standard way of structuring the healthcare data in terms of format. On the other side, what about the structure of the text itself? Unfortunately, there is no structure. Typically, these are free texts we're talking about. Sometimes some organizations in healthcare, they use some templates, but mostly the narratives are kind of unstructured, which makes it quite challenging. On top of that, the language itself, for instance, let's look at the radiologist when dictating a note. They're quite telegraphic. They're quite basically short in describing events. And this is just because of the nature of the job. Like they have to go through a lot of cases. And as a result, they have about 40 seconds to spend per case, and they have to describe whatever they observe and plus the action they recommend in a short amount of time. So it turns out to be a lot of abbreviations that are not very standard, a lot of telegraphic way of mentioning things. So that's yet another challenge to add to the list. In terms of common tasks of application of NLP in the healthcare space, I also try to divide into 4 themes. I start with the more general one, which is having this free text, being able to structure it. So for the downstream tasks, so this could be used for the basically decision support for a radiologist, for a physician, etc. It could be for analytics, population health management, etc. It can also be used for a common application, which would be classification. A common example of classification is in pharma space, and that would be clinical trial matching. So there are lots of descriptions about different trials, but being able to put the appropriate patient into the right track, it's still a challenge. And pharma companies start to adopt these NLP technologies to help them to better classify the patients. Moving to the next common task, it would be a Q&A. The doctors would love to have a capability that by using some sort of a narrative language, ask the question about a patient, and then the engine behind the scene crawls through all the data about the patient and provide you with an answer. And if you want to ask about where did you figure this out from, you should be able to show the evidence for it, that from this document, I found this answer to your question. GPT-3 is doing a great job for that for general language. Not so sure about the healthcare. Healthcare has its own challenges and its own technology development is required. And finally, I would consider it as also a common task, the prediction type of task. So given all the events about the history of the patient, can you help me know what's the next likely event to happen about the patient, a heart attack or another common problem given all the symptoms that we have been seeing in the past. What is a typical NLP pipeline for healthcare applications such as the one I described? Typically, you're given a free text, and it's digitized. Let's avoid the problem of OCR at the moment. For the sake of example, I'm taking a snippet from a pathology note, which describes the specimen location and some attributes about that specimen. In this case, about the prostate biopsies. The location is left prostate, and the Gleason score, which is a way of grading the cancer, is described as you can see. So what I want to get out of this is being able to structure this information. Where is it that I'm getting this specimen from, and what is the grade or the type of the cancer? So the very first step typically starts with pre-processing. Many people underestimate the impact of this pre-processing on the downstream tasks. For instance, in the sake of this example, the space between the numbers, if we don't take care of it, what is going to end up, it avoids this whole entity to be captured together. So pre-processing hopefully takes care of that for us. The next step would be sentence parsing. So meaning that break my document into segments that are kind of separate from each other, at least in terms of sentence boundaries. Once I have that, the next task would be tokenization, meaning that breaking down the sentence into individual words. And then from there, we move to finally the downstream machine learning AI task. In this case, would be structuring the note for me. And if I don't do these prior steps properly, I'm just going to make this machine learning task much harder and deal with a lot more noise. There's a lot of capabilities out there, off-the-shelf tools for doing these kind of common tasks, but I don't believe we are there yet. And as a result, I want to show some examples. Let's take a note from MIMIC3, which is a publicly available radiology data. Let's look at the sentence parsing. This is the common tool used for sentence parsing. Off the shelf, SPIE for general language works great. Let's see how does it perform on a basically clinical document. As you can see, the parsing didn't do so well. Even like, for instance, these lines of underscores, continuous underscores, every basically occurrence of it has been detected as a separate sentence. Let's look at the NLTK, another common tool. This whole header part has been segmented as one sentence. And finally, in 2020, Stanza from Stanford NLP came out, which looks very promising, and it has even an NLP related to healthcare tuning embedded into it, which looks like from our first test providing impressive results. So it's very important we pay attention to these steps and we choose the right tool. And if the right tool doesn't exist, that means we have to build it from scratch. In the tokenization, I have similar examples. This is a snippet of a pathology note. And you can see that SPIE, the accession number that is being tokenized is broken down to pieces, which breaks down the whole structure of it. So it's going to be down the line harder to deal with. The date has been broken down in a wrong way, and etc. Stanza does a much better job again, as we can see. So the tuning is pretty good. But again, let's say if I would like to extract the Gleason score as a 3+4, Stanza's capability also not sufficient for that. So I need to add something on top of it. Downstream tasks, I put a couple of examples that we have been working on it, for instance, a CodaMetrix for name entity recognition. This is basically a snippet of a radiology note, and the goal is to extract entities and concepts such as diagnosis, testing, and treatments. As you can see here, they're being detected. And if you do a good pre-processing and tokenization and sentence parsing, downstream tasks is going to be much easier to be successful at. Another example would be a classification task, such as anatomical labeling. Basically, for the same note, try to assign an anatomical label per sentence. So in this case, we did some effort in that space. And finally, in terms of the prediction task, I chose computer-aided assisted coding. That means assigning procedure and diagnosis codes given a textual context about the patient. So there are lots of players today in the development of NLP for healthcare. You name it, IBM Watson Health, Azure, basically medical comprehend from Amazon, etc. So it's very important we deal with the correct selection of the tool for our application and make sure that it's doing the job expected from that tool. A typical way of adoption of these technologies is you start with a pre-trained model. And what you do is you bring your own application data. This is annotated label data or hospital-specific data. You do a fine-tuning of this pre-trained model and you create a fine-tuned model. Then you start putting into application, you bring a new note and you realize the performance is not there. And what happens? You go back and start adding some rules in there. In this situation, in that case, don't listen to the fine-tuned model's outcome, do this. There's no problem with that. The way we should look at this is that's okay, but we have to also take advantage of the information that we are gathering as this updated model. So sample your output, do some QA with the experts in the domain, and use that knowledge to improve your rules as well as update your data, and then do the fine tuning again and obtain your pre-trained model. This is kind of referred to as active learning or continuous learning. What is the future is going to look like for healthcare? In my perspective, the scaling and generalization is the biggest thing to basically address. A lot of tools these days we are using and dealing with are lacking the scaling and generalization, and the domain adaptation is really a no-brainer for healthcare. But at the same time, that doesn't mean we should add just complexity and the footprint of our models. We should also at the same time watch for reducing this complexity. So it's affordable for all basically users, not just the ones that they can afford training a model with hundreds of billions of parameters. Another interesting future for healthcare specifically is federated learning. You start with a universal model and then fine-tune based on data from specific organization. This is also interesting because you avoid the transfer of sensitive data outside of the organization for the tuning and for the training purpose. And what I would see as more into the future, so that was immediate future, is sometimes we create problems and then try to come up with a solution for. So the radiologists currently dictate the notes, whatever they see on an image as an example, let's take. And then we run NLP or build NLP capabilities to structure that data. But why do we need to go through that? What's the point of this is to create useful information for the physician for the next time the patient comes, so we know and longitudinally we can track the data. What we could do is like basically immediately turn it to an action, turn it to a structured data rather than create a narrative and then struggle to build an NLP work on that narrative. So this is the way that I see the future should look like, basically immediately going from observations and findings to actions and structured data to avoid these like intermediate problems that we struggle to solve. But I would like to finish with a word of caution, specifically building capabilities in AI and NLP in the healthcare space. The way we look at these is we typically measure our performance in terms of true positive, false negatives. But that's great for applications if you're detecting cats and dogs, right? Because if you make a mistake, if I say a dog is a cat, it's not the end of the world. But in healthcare, if you miss, if you make a false negative, a false positive, you're talking about lives. So if there's a screening program and because of our NLP, we didn't detect the symptoms correctly and that person doesn't go on the screening program and that cancer develops, that's what matters. So I would like everyone to pay attention to the true meaning of false negatives and false positives if you're working in this space. So with that, I would like to close my talk, and I would be happy